Okay, lesson 1B, which is still on the 2019 emerging technology discussion and also looks at some other hype cycles for 2019. So this is a totally new presentation from last year. I de-scoped the previous year's ones and put them in the 1C and 1D. So the first slide here, the set of slides actually goes through the technologies, those that were added, those that were removed, and those that kept on going. Here we have, and I actually divided them up into types. Some large number, which I think are largely AI, adaptive machine learning, personification, synthetic data, transfer learning, emotion AI, describing whether you're happy or unhappy, explainable AI. When you feed something into a billion-way neural net, it's not quite obvious why the neural net makes that decision. Generative adversarial networks generate copies of the objects, which are distorted or not so real, and that's very powerful. Graph analytics is a very difficult field. It's one of the hardest fields in computer science. Graphs are the algorithms are very tricky. They're hard to make run fast and hard to find in the first place. Augmented intelligence, which is the adding of machine learning to people learning. Here we have the 2 in the augmented and virtual reality area, and 4 in the systems and AI area, starting with the systems and AI plus AI. Everything has AI. The autonomous organization, that's a distributed system which has AI enabling its functionality. The decentralized web, which is your personal operating system of the future to let you control the web. Digital operations, which is the producing entirely digitized businesses. Edge analytics, running that machine learning code, which would rather take several days to train on the cloud, running it in a few milliseconds on the edge. That's not trivial. Immersive workstations, now we're getting onto the augmented and virtual reality, were added, and that's obviously the environment which you indulge in either augmented reality or virtual reality. The AR cloud is a special augmented reality concept of actually generating a digital twin of the physical world. Here we have 5 in the sensors and hardware area, the 3D sensing camera. The low Earth orbit satellite to enable high-speed global broadband and enable the intelligent edge to work throughout the world. Nanoscale 3D printing to produce miniature 3D, very powerful little objects. Next generation memory I've already discussed. It's important. It's essentially taking this technology and refocusing it as memory technology, because especially actually in deep learning and the other machine learning, they're all memory intensive. Then we have the light cargo delivery drones. That's allow Amazon to deliver everything instantly. Make it even harder to get your shopping mail to survive. Here we have ones that were present in 2018 and still present in 2019. Knowledge graphs, AI platform as a service, edge AI, and 5G. They were present last year and they're present this year, and they all should be here. Very important innovations. Here we have things that went from 2018 to 2019, and 3 in the sensors and mobility area. The 2 autonomous drivings, level 4 and level 5. It's depressing that level 4 is already 10 years late, 10 years out, whereas of course hopefully people thought level 4 was a couple of years and level 5 years. That was the original hope. And there's this organization called SAE, International Engineering or International Collaboration, that define these names. And then we have flying autonomous vehicles, and these are aircraft piloted by artificial intelligence, and we know all about drones from discussions between the military services of various countries, which we see on in our internet news feeds. Here we have two from the augmented human, biotech, artificial tissue, biochips, which are implanted to allow me to my vision to improve, or my hearing to improve, or allow me to run a mile in 3 minutes, and so on, whatever this technology allows me to do. Pretty good. I like it. We have 26 technologies were removed. We gained 20 and lost 26. I said it's a little smaller than last year. If you look at them, quantum computing, I would have kept. I would have kept autonomous robots. At least we got rid of all the robots. I would have kept at least one of them. I consider deep learning should have been kept, even though they kept some parts of deep learning. Deep learning itself still needs a lot of important work. There are going to be many startups just developing whole new approaches to cosmic deep learning, whether it be new chips, new software, new algorithms. So they actually said for these 17 like deep learning, not that they'd actually matured and jumped off the plateau of productivity, they just needed room. So they just said these are not as exciting to me as the other ones. We gained 20, but we lost 17. 9, they genuinely thought had actually made enough progress. It's like digital twin, augmented reality, that they shouldn't be anymore there. IoT platform. I should say that some of these things which are not on the emerging technology hype cycle are on other hype cycles. So they're not lost forever. Like cloud computing itself is on other hype cycles. If we look at the hype cycle for artificial intelligence, we actually even have quantum computing here, because it actually gets used to do quantum annealing. Maybe that's why they put it up there. It doesn't. I don't quite see it being that useful for AI apart from quantum annealing, which it is pretty interesting for. We have digital ethics, GPU accelerators. That's NVIDIA. That's why stock price has gone up. Well, it's Bitcoin plus GPU-based deep learning is why NVIDIA has done well. But Intel with TPUs are fighting back, and actually some people think they're better than GPUs, except that Intel doesn't sell you them, so that's life. Here we have edge AI, smart robots, chatbots, automatic finding of hyperparameters for machine learning, ethics. Here we have the basic deep learning here. We have the graph analytics, which is actually also in the emerging technology, and even basic machine learning. I would actually put a much bigger distance between deep learning and machine learning. Machine learning is a well-established field, and outside graphs and deep learning is not making much progress. Natural language processing, that should be separated. It's a very important, one of the greatest successes of deep learning. FPG accelerators, well, that's some sort of possible approach to speeding up things. I don't think it will be. It's too difficult. Computer vision has made huge progress. I pointed out we have 1 trillion photos taken a year. So that's allowed us, the whole field of computer vision has gone from a slowly moving field into an express going faster than the speed of light. AI clouds, neuromorphic hardware, that's specialized hardware mimicking the brain, and so on. Artificial general intelligence, the ultimate goal. Build a machine that really can think like humans can. That's what artificial general intelligence is. Okay, here we have the priority matrix for those AI innovations that we had in the previous slide. And we have things which are transformational, pretty nearly done. That's speech recognition. I think most people would agree that that's a pretty robust field. GPU accelerators, I think that's already solved. Quantum computing, we got it. You see, here it is, but it's more than 10 years. The significance of quantum computing for AI is not so clear. Its main claim to, they say quantum annealing works, and that's a machine learning, that's a optimization technique of some probable value. But it's not going to replace your basic deep learning. Here we have autonomous vehicles, more than 10 years, transformational. Of course, artificial general intelligence will be transformational, and hopefully is more than 10 years, because we really don't want to be replaced by machines before we're ready to do it. Neuromorphic hardware, well, it's not actually known how important that is. It's never known how important specialized hardware is. It all depends. If the algorithms are very stable, then you can build specialized hardware to mimic them. If the algorithms, like they are now, are changing overnight, then it's not so easy. Here we have Edge AI, where we are trying to get the low latency response, but still accurate. We have the deep learning itself, which I think will last more than 5 years, because there's so many deep things to be studied. Well, I shouldn't say deep. So many difficult, profound things to be understood about deep learning. AI cloud services, I would think, is much easier than deep learning. We know how to do AI cloud services. It's just a question of beating a few people over the head and installing services, taking every all our TensorFlow implementations, making them a service, and make our Python code invoke those services. So it's not difficult. AI platform as service, well, I've told you my platform as service, Python plus services. Digital ethics, yes, that's an explainable AI. Those slightly soft areas are pretty important. Graphs, I've already told you how important graphs are. And graph analytics is what operates on knowledge graphs. Reinforcement learning, very important. Whether it or I'm sure it's more important than cognitive computing. Whether it's more important than whether they put we haven't got these people don't seem to have generative adversarial networks. Interesting. Whereas the actual main emerging technology had that. Just shows you the different analysts have different prejudices. Computer vision. Well, I'm not certain it will be solved in 5 years, but it's certainly making huge progress. Specialized integrated circuits for deep learning can certainly be done at that time. How useful they are, but they have to be redone, I don't know. Automatic finding of the so-called hyperparameters for machine learning, that can be done probably in 5 years. All right, so here we are. And this sort of gives you an idea. I can tell you, you can say from my discussion that I think some of these are pretty fuzzy and I wouldn't personally agree, but then I don't think these are way off. I would just juggle them around a bit. Here we have the Hypecycle for cloud computing. Here, I'm much more, I think this is actually an easier one to do because cloud computing is so robust. Here it is, here, and it's up the slope of enlightenment. And here is the main original technology, making applications run as a service, software applications. And here we use platform as a service and infrastructure as a service to implement that. Here you still have exciting things like serverless computing at the top of the inflated expectations. We have what I think is pretty interesting, the service mesh, which is the technology that allows you to connect a whole bunch of services together and with communication and management and automatic elasticity. Cloud native is important. That's the way to program clouds in a way that really takes advantage of their structure. Blockchain, secure ledgers, distributed ledgers is pretty important. Cloudlets is the basic edge computing technology, at least their name for it. Not everybody would call it cloudlet. I wouldn't call it cloudlet. Multi-clouds. Here we have the technologies to support lots of clouds. All of these things were described in the cloud computing unit. IoT platform, that's off the chart in the emerging technologies. It's relevant for cloud computing because the intelligent clouds talks to the intelligent edge, and the IoT platform must know about the intelligent cloud to do the right things. And here we have the priority matrix for that. And we have at the top cloud, we have the two basic ones at the top in less than 2 years. Edge computing, platform as a service. And whether these things like, I would tend to agree, well, I think these are actually straightforward. AI platform as a service is not difficult. They won't take 5 years. Well, it will only take 5 years because people don't agree. It can certainly be done in much less than 5 years. Cloudlets, well, actually, I think it's harder than AI platform as a service because we don't quite know what it is. Containers and their management is critical. It will be solved in 5 years. Infrastructure as a service will, it's sort of already solved. Multi-cloud will go as far as it can in less than 5 years. Cloud bursting, going from private to public clouds. Yeah, we can certainly do that. Private cloud computing we can do, except people won't be happy with it. Blockchain we can do. Again, it just needs deployment experience. Serverless, I would have rated serverless as more than moderately important because it actually is the right way to do infrastructure as a service because nobody wants to worry about infrastructure, and that's what serverless does. It automatically deploys the services as software. It doesn't worry about deciding exactly which computers to use. It just looks around the running computers and finds the emptiest. And so it does it all automatically. And Amazon loves it because it uses up spare cycles. The users love it because it's cheaper and it's only charged by the time used. It's not charged with minimum charges of an hour or so, which a real machine is. All right, so that's the end of Lesson 1B, which is the discussion of the 2019 Hypecycles. The next 2 lessons you could almost skip because they're just previous year's discussions of technology cycles. Thank you very much.